Hi. Hi everyone. Thank you for tuning in. My name is Junior. A little bit about me. I've been with Red Hat for a year and a little bit over a year. I'm in the Rados team, and I also worked a bit on Teuthology. And today I'll be presenting how we can run Teuthology locally using CPU labs as test nodes. So the problem that we faced when we try to make some changes to Teuthology, making it better, is that the installation process is very difficult. Teuthology contains like 5 different services: Postgres, Paddles, Popito, Beanstalk, and so getting them to work all together is kind of challenging, and as well as like different developers who want to contribute to Tautology also has different, environment like operating system packages. So our solution is to automate this setup process using Docker containers and create like clear documentations on the parts where it cannot be automated, such as adding like the machines to the test notes. Um, and yeah, and I guess the use case for this is definitely, as I said before, Tautology developers who want to contribute, as well as external contributors, such as interns from Outreachy and GSOC. We've recently posted a project on Outreachy and GSOC on making Tautology better at detecting unit test cases. So this Tautology setup script will enable these interns to get started on contributing to the project. And the last case is basically Ceph developers who can't wait for their scheduled job to move up the queue. So they can just create their own Tautology, start it on locally, and then you know and lock some test nodes and use it for themselves. I don't recommend you use it for this case, but I gotta cover all the cases. And yeah, I'll go right to the demo side of things and how you can set it up. First, what you want to have is a Tautology config file, and this can be done, I'm assuming, if you have access to Tautology lab. It's in this directory, and basically all you have to do is copy paste the whole thing to to your own to your own thing in the same directory level as the README file, as the cloned Tautology repo. And then you have to change a bunch of things like lock server, result server.
Sorry, can you go back to what copy what to where? I'm not sure I understood.
Um, so you wanted to SSH to into Tautology, um, and then copy the .tautology.yaml file. Does that make sense? Like the
Yeah.
tautology that tautology.yaml file is the configuration for tautology.
Yeah.
It's configuration files. So basically, you copy that um, to the same directory as you have here in the tautology Docker docs, Docker compose, um, as the README file. So basically, I already did that because I don't want to show like the process because it will, there's some sensitive information regarding like IP address and stuff like that on tautology config file. So I already like did that on my part. Here, it should be here. Um, and yeah, you have to change a bunch of things like lock server, resolve server, queue host. Basically, if you can follow these steps, you should be good. Um, yeah, we want to keep the reserve machine 0 because I think the default requirement for reserve machine is like 2. Therefore, if you don't have like 2 machines available in your tautology, it won't start running jobs. So you keep it the minimum as 0. So even though you have one tautology, the one test node, it will run the job. Okay, so next part. Oh, before I want to mention as well that you should have Docker installed, and also in this case you want to have like a VPN access to the CPU lab. So yeah, you need VPN access to in order for you to be able to, you know, grab the test notes, lock the test notes from Teuthology and add it to your own local Teuthology. And make sure that you have the VPN running before you start the Docker process, because sometimes it can mess up the network. Yeah, that's something I realized. So next, what you want to do is you want to run a start script. What the start script does is that it clones another Teuthology repo, and it builds it using a Docker image of Teuthology, and it also runs Docker Compose. And I'll go while it's running. The process you see here will be faster here because I already have the images built here. It's only the Teuthology image that is not. It's there, but yeah. But you might find the process like slower when you do it on your own. So in the meantime, I'm gonna explain to you how like Docker Compose side of thing works here. So basically, we have 5 services for Teuthology. We have Postgres, which is, as you know, is the database of Teuthology, and basically we have we get the image from I think Docker Hub here. So it's pretty much a standard way of using Postgres here in Docker Compose. And then the next service we have is Paddles. You can grab the image from p.io, which is where the latest image of Paddles is. And these are all just environments that we set for it to connect with Postgres. And how it works is that Paddles will wait until Postgres is finished, doing its thing, installing and getting up and running before it's actually will start installing stuff, building its image. You can see here it says depends on Postgres. So the condition of Postgres has to be healthy, and how we check that is using this command line Postgres is ready. And you can see here the Paddles health check is basically a curl to the to Paddles URL itself, seeing if it's up and running. We expose it to port 8080, and so such that other services can interact with it. Pulpito here also gets the image from e.io, so we don't have to build. Basically, you don't have to clone the repo and build the image. And yeah, a bunch of environment stuff, and then the health check for that is also a curl. And we have the Beanstalk service where you actually have to build it. The file is, if anyone is interested, the directory is like you go to before and then you go in Beanstalk Alpine, and you can see the Docker file for that, and you build that. And Teuthology, and lastly we have Teuthology. We also have a Docker file for Teuthology. It's right here. It's very similar to if you go on Teuthology documentation and try to set it up locally without using my script, our script. You have to run like Bootstrap and everything like that. But in certain operating systems like Ubuntu, the Bootstrap will prompt you that okay, some packages needs to be installed in order to do it. So we kind of automated that process, as well as we create a directory for archiving all the runs, as well as archiving the logs for the Teuthology. And we actually run a Teuthology suite after we finish with the Bootstrap to schedule a dummy job, which is for the sake of sanity, where we'll make sure that this is how we make sure that okay, after in the steps you see in the future here, that we are running Teuthology correctly. So yeah, I'm just waiting for it to finish. I can answer any questions in the meantime if you guys have any. Yeah, okay. So as you can see here in the logs, that we schedule a dummy job, and how to share the screens correctly. Okay, but do you guys see a torpedo by any chance?
Yep. Yes.
Oh, okay, okay, okay. So you go to where Popedo is localhost 8081, and okay, you can see there are two jobs right now. This one was I forgot I didn't so before this I did a test demo before, and then I forgot to stop the containers, but it's fine. So this is the new job that we have in the queue here now, resulting from sorry, from this part of the Docker file where we schedule a dummy job. Okay, so moving on, this is the part where you want to add test nodes, right, to Teuthology. And so what you need to do is you need to have like a private key in order to connect with the machine in Sepia. So what I'm going to do is I'm going to go into the Teuthology container, and I want to basically, like, this is a manual process, so I need to create like a directory and basically copy paste the ID RSA. So for folks who have access to the CPU lab, you should have this in your like machines that you use to access. So it'd be exactly like ID RSA. I just have that handy in file. I'll just do that quickly. So hopefully you can't really see what my key is. Yeah. And give that a permission of 600 so that way it works. And also it's good to have a config file here, just so it doesn't check the known host file or host key checking. I'll do that real quick. I'm just going to give that a 600 as well, just for sanity. And yeah, moving on to how you actually reserve a machine. For the demo purpose of things, I know that it really depends on how busy the Teuthology in production is. So what I'm going to do is I'm going to try to lock like a Smithy machine from the CPU lab, and then add it to my local Teuthology as test nodes. But I kind of cheated this process and already locked one beforehand just so it works. So my machine is Smithy 198. But yeah, so if you have to lock it, you use this command. So this command will be run on you have to SSH into the actual Teuthology in production and lock the machine. You give it this command, it will lock one machine for you. You also want to update the description of the machine. You can see it in Popedo, in the production Popedo. You say like, oh, I'm locking this for Teuthology development purposes, so that people like won't wonder why you're like locking the machines to yourself. You want to mark it as down as well, and yeah, I've already done that. I don't think I have to show you, but I've already done that for Smithy 198. So So yeah, moving on to the actual process of adding test nodes to paddles. You go to you activate a virtual environment, and you go to this file. So this Python file is like a script that you run to basically add the test nodes to your inventory in Teuthology, in your local Teuthology. So see, here I'm still in my local Teuthology. So the things I would need to edit are a few things. Sorry, this small, I know. Is the paddles URL. It should be the same as the URL you have in your local Teuthology. The machine type should be Smithy if you are adding the Smithy machine to your inventory. Lab domain should be front.cpl. You know how it goes. And user is Ubuntu without password. If you have like the ID RSA and you're on the CPL VPN, you can just access it without the need of having a password. And this is also a part where you specify the number of machines that you are adding. I kind of want to change this since it's in range. That means it's like a list of machines. It's assuming that you have like a list machine, but in my case, I have only one, so it would be 198 to 199. Let me just double check real quick if it's actually 198 that I already locked. Messed up. Yep, it's 198. Okay. So after you edit the file into your local Teuthology, you can run it. Hopefully, it will. Oops. It should work. Okay, so it did work. So how do you know if it works? So basically, you want to have some output that is similar to what you have here. If you have something that is not something like this, has something like error, failure, yeah, you're probably not adding it correctly. It might be to do with the network. Like check your private key that you have access to the CPU lab, your VPN, if you're not running on a VPN, and yeah, just network related stuff. And oops, actually mine might fail, or either that or I already added it in my last demo run and I forgot to restart the Docker containers. But anyways, I'm gonna go to the Popito by okay. Can you guys see Popito?
Yep.
Yes.
Okay. Yeah, so you can see here we have one node that has been added to our inventory, 198. So it is locked at the moment. What you can do is unlock it because you can't run we can't run any jobs while it's locked. So what you can do is, let me just change back to VS Code. Okay, what you can do is use this command where you unlock. So this we're still in the local Teuthology, right? Because we already have the 198 Smithy. in the inventory, so we can do that. You want to unlock it, and you have like the owner name. It's called initial setup just because the script that I use to add the test nodes to inventory is the default is that name, but you can change it. You just have to change the script in there. So yeah, I run that. Okay, I need to get off virtual event v first. Deactivate. Okay. Yeah, something's not right. Let's see. Yeah, so I have some trouble. So basically, I didn't really clear I think I forgot to actually like remove the process, I mean the containers for paddles correctly. So it still has 198 in there, and then for some reason there's some mistakes, but yeah, but I'll just move on. Just take my word for it. um, I'll just move on to the
We can
part where
take note
let's
of
say yeah,
we can
yeah,
take note of what not to do. No worries.
yeah, yeah. Sorry, I didn't. Yeah, I the practice demo I did before this, yeah, kind of messed it up. I didn't delete the
Hey,
container.
Junior, can you show pulpito again, please?
Yeah, sure. Um,
Oh, I see. Okay, so this is local pulpito. This is not
yes,
Ceph.
yeah. This is not Ceph. This is
Okay.
local Pupito that I created. Yep. Okay. Um, VS Code. Moving on. Creating Ansible inventory. Okay, I gotta be honest on this part. It's I don't exactly know why, like the inner workings of like Ansible, CM Ansible and stuff like that. But in order for us to successfully run a Ceph job that has Ansible task, that the majority of Ceph um, tests uses Ansible, right? So in order for us to run it using our local Teuthology, we need to add the Ansible. We have to create an Ansible inventory, and we can do this by following what is already in production of Teuthology. And Teuthology has this file called smithy.yaml. It's in this directory. So what you do is you copy paste you create the directory and basically copy paste this part. Just this part. It has other parts in it, but you only need this part to get it working. Not that. And then I don't think that's correct. But yeah. Yeah. So this is very like manual thing to do. Like again, improvements is basically try to limit as manual process this as possible. Okay, so we have that. Copy and paste it. Next, we need to create like host machine configurations in the Ansible host cpeer directory. Basically, if you go to this directory in the production Teuthology, it have like a lot of things. But what we want to concentrate is like if you are using Smithy, just Smithy, and you have to add this test node children and Smithy children as well. And you need to add like the actual like information of each machines. So for me, for this demo, we only have 198, Smithy 198. So all you have to do is add 198. So you go into the actual Smithy production, go to this directory, and copy paste the actual 198 information. So I'll just demonstrate it, but I won't be actually copying the actual MAC address because that's again sensitive information, and I don't think we should be exposing those. So for me, the jobs that I had on queue is a dummy job, so it doesn't really require like running like Ansible tasks, so this wouldn't matter. But for running like real Ceph tests using like the local Teuthology that you just set it up, you need this part for it to work for sure. Yeah, 98, thing like that, and yeah, copy pasted, bunch of stuff. And then you get to the last thing on the list is running the dispatcher. For those of you who don't know, the dispatcher is basically a process that gets stuff out of the queue to run jobs. And basically, we need to run this for it to happen. We need to start this for the jobs in Teuthology to happen. So yeah, I can just describe a bit. The archive directory is basically where you archive the jobs information, like the job folder for dumping all the logs for your jobs. And then a log directory is like the logs from Teuthology itself, and tube is basically like the name of your machines, your test machines. And so if you have like other machines than Smithy, you have like different like tubes. So let's see. And I think while that is running, I can answer any questions if you have any.
Maybe this is obvious, but remind me how you would find the IP and all that information if you don't have access to the CPNO, like if you don't have the VPN enabled. Is that information that's documented somewhere?
Do you mean like this part or?
Yeah.
Yeah. Okay. So, my presentation is my demo is basically we're assuming that you have access to CPLab, but the good news
Okay.
The good news is I will show you like I'll talk about it like future works that we have right now. We can run Teuthologies and use containers as test nodes, so you don't need access to the CPLab in order to run jobs that doesn't Ceph jobs that does not like interact with the kernel or test the kernel, because containers the kernel wouldn't be changed. So anything that doesn't touch the kernel jobs you can run with using containers as test nodes. And Zach is the one who has been working hard on making this happen, and I'll be talking a bit more in the future slides. Okay. This is a bit long. Yeah, so basically, like right now, because of some technical issues I had, we this node is locked. I tried unlocking it, as you see from the previous steps, but it didn't work. So if for it to happen, I need to restart everything again, and that would take some more time. But yeah, sorry about that. So yeah, you just have to take my word for it that if you do it correctly, it would work. And basically, this job would be running, and it would complete. So you have a green on it, and yeah. So that is it for the demo. Do you guys want? So there will be like more slides regarding future works and stuff like that. But if you guys have any questions regarding the demo itself, like anywhere you want me to go through again, you just let me know. This is a good time, I think, since I have the README open. I'm just gonna change that. Okay, I can go back to the slides. Okay. Everyone sees the slides.
Yep.
Okay. So yeah, future works and improvements that I wanted to do with this is to automate some of the manual steps of adding test notes to the inventory as much as possible. I think Zach today actually we had a discussion of how he can actually do this, and I believe he'll be able to do it. And yeah, we'll work on that in making it more automated. But the good news that I talked about before is that we are able to run containers. It's almost done, like 98%, I think, right, Zach? Using containers to test, yeah.
Yeah, so I'm happy to talk about this a little bit. So when Junior first did this work, I got really excited about it, and I wanted to see how far we could take it. So this work is still in progress. I filed a draft PR on this, which I can link for you guys in a second. It's the state that it's in right now. It's not ready to be merged yet. But so the first thing that I started working on was I wanted to see if we could get containerized test nodes working. So this took quite a bit of effort and required, I don't know, like a dozen PRs to Teuthology and friends, because we have to skip a lot of tasks and certain operations inside containers. Junior was talking about this a little bit earlier. So running Ceph tests may or may not work really well. I'm not sure using containerized test nodes. But it does help us a lot with testing Teuthology itself. So I'm also intimately familiar with how our provisioning and stuff works. Junior was talking about Ceph-CM Ansible a little bit before. It will be possible to automate the inventory related steps around this for using bare metal test nodes. So I think ideally what we're going to end up with for the use case of using bare metal test nodes is, well, of course, you'll still need VPN access or access to some lab, right? This in theory could work outside of Sepia. You will need to, of course, have locked the nodes inside the real lab. But then ideally we'll be able to take just say like a list of the host names that we're going to be using, take that as an input, and then take, I guess, the URL to the secrets repo, which is where the inventory and stuff is actually stored that we use in production. So then, assuming you have some kind of access to that repo, you'll be able to have it cloned, and then, rather than having to SSH into the Teuthology machine to copy some fragment of its inventory, you'll just have the real one. And then so all the data that we need to run Ansible successfully is keyed off of the host names. So it'll all kind of just work slightly more smoothly, I think. Personally, the part of it that I'm the most excited about is like being able to run the entire stack inside of, say, GitHub Actions on every pull request. I think it should make Teuthology development a little bit safer and faster. So that's kind of the summary of what I've been working on. Um, I will paste that PR in a second if anyone cares to look at it. Uh, yeah, that's about it. Happy to answer questions or elaborate on things, but that's kind of the gist of it.
Yeah, yeah, as Zach was talking about before, um, yeah, also allowing devs to choose between using containers or bare metal machines as test nodes. Um, so um, that'll be something a really cool feature we have, and again, it really improves for Teuthology devs. It helps Teuthology devs when working on features, testing it out. But the
If I could
ultimate,
add one
yeah,
thing real
go
quick
ahead.
here that I should have
Hmm.
mentioned. I think the
Sure.
key part of the summary for the containerized test nodes thing, the advantage is you don't need a scrap of access to Sepia at all. The entire thing can work on like your laptop, no VPN. Um, that's the trade-off you get for not being able to run real Ceph tests very well.
Yeah. And ultimately, the ultimate goal, I think, is that this is a very reach goal, but I think I've talked to Josh about this, and if we can somehow use VMs or bare metal machines as test nodes, and we can give like Ceph developers an option to skip the process of pushing it to Ceph CI and build on Shaman. Basically, you build Ceph once locally, and you basically like somehow use make Teuthology use the or make the VMs use like the binary files to run any like tests, any Teuthology test basically, and then you already have Teuthology set up locally. So I still haven't got the details of it right yet, but as far as I like talked to Josh about it, this is kind of like the ultimate goal, and I think this would really like help increase the productivity of Ceph engineers, so you don't have to wait long for your stuff to build. If you can build it locally, you can also. But I can see the drawbacks of like using VMs locally because Ceph is like it you know it's pretty heavy, so your local machine might not be able to handle it, something like that, you know. Um, but yeah, that's our ultimate goal, which we'll be excited once if we reach it someday. Um, and yeah, that's about it for the future works and improvements. I want to acknowledge like people who also helped with making this happen, making the Docker script for creating a developer environment. And, you know, Ashwarya, David, Josh, Pierre, and Zach, you guys have been really helpful. It's been a long process, but couldn't have done it without you guys. Um, and yeah, I think that's it. And I'll leave the rest for Q&A. Thank you.
Yeah, just to add on to the idea of it being a resource intensive on a local laptop, um, going along with this project, I think it'd be good to emphasize that you could that users can specify, different facets that they want to test, or just they can filter out only the jobs they need. And of course, that's already possible, but just putting an emphasis on that for people doing this on their local laptops, that would probably cut down. Like, they don't necessarily need to run their tests through the whole Rados suite every time for it to still be effective.
Yeah, yeah, yeah. That's a good point. Any other questions? Anything you want we need to go over again, or any questions to Zach on the future works on the containers, PR? Yeah.
If there are no more questions, thanks, Junior
Okay.
and Zach, for doing this presentation. I'm sure a lot of people did not know about this and are excited about it. I think we should do another one once we get the containers one merged, and we can get a checkpoint as to what we are going to do next. But this is really useful. Thank you so much.
Thank you guys for joining.
Thanks, Junior.
Thanks, everyone.
Thanks,
All right.
Junior.
Thank you.
Thanks.
This is really good.
Thanks, Junior.
Good day, everybody.